We're back. And we're live here on of course, I didn't put the proper coding, which I'll have to re-inquire. I always forget. But we're live here with COMP397, web game programming at Centennial. And we're lesson 9 today. We want to talk about collisions and collision handling and all that kind of stuff. What I also want to bring up is stuff with VS Code. So if I bring up VS Code here, and again, I've got some stuff that I was working on from before. Let's bring up that stuff from COMP397, our course that we're doing today, and then see how it goes, how it works out. So if I'm not wrong, somewhere on this bloody mess, there it is. Then I have this mail pilot demo that I want to use. I'm just going to pull this in. And remember what we were doing last time? We created a module, the plane class. So I'm going to run this thing in the like this little HTTP server, like I did last time. So what I'm going to do is, again, I'm going to just further down here. I'm going to kind of right-click and then kind of open in terminal. And of course, I love when it does that. It doesn't work, right? That's okay. I'm going to go CD. I'll just do the long way. And then I'll kind of type that in. And then I'll write in HTTP server, so it'll be serving up my files, right? So I use the npm module HTTP server to make sure that I don't have any other issues. And now I'll go on the website, and I'll go localhost 8080, which will bring up my mail pilot. This is where we were last time, right? Okay, so notice how it kind of flows. We want to talk about collisions today. That's what it's all about. So we'll talk about that, right? Okay, I'll minimize this. But let's talk about Visual Studio and how to transpile with VS Code again, because I know some people are having issues with this whole thing. How to use it, how to transpile. So a couple things. When you set up Visual Studio, the one thing you need to do is set up the task runner. And the task runner should look like this. Let me try and show you what it looks like. And by the way, this works Windows and Mac. You don't have to put anything special inside of this thing. Let me just get rid of all this stuff so we just can save ourselves some configuration and so that you see what it's looking like, right? So one thing is you don't need anything more than this, even on Windows, right? So this piece, what's that? Tell me.
Linux.
Linux again? What do you mean? You want me to do things with Linux? You're going to do Linux? You want me to do Linux now instead of like, oh, geez. You're really challenging me now. Yeah, I can do Linux. It's not a problem. It's the same thing anyway.
Yeah.
But thanks, Stephen, for that. So if you notice, these are the things you need in your tasks.json file. So if all you have is this, that's what you need. So let's make sure that you configure your task runner so it just looks like this. You need to have TypeScript installed on the command line. That's the one thing you need. Remember we talked about this last time, right? So if I bring up I'm just gonna stop doing my debugger here. You need to have, so if I go to TSC as an example, press enter, I should be able to get something that does one of these, TSC minus version. I should get something like 1.6.2. If you're using a Mac, it should look like this. If you're using Windows, it should look like this. And if it doesn't look like this, then it's something wrong with your installation. But even so, you should still be able to run TSC locally on the command line, which should be fine, okay? Now, if your version is not 1.6.2, that means you might have compatibility issues with me when it comes to using Visual Studio Code, right? If your version is 1 point something, 1.1, 1.0, it'll work, but you may have problems with the TSD files, right? The TypeScript definition libraries, right? So that's the piece you need from a configuration perspective. That's one of them. The other piece you need is, so this is one piece. Let me just collapse everything here because I think I need to kind of collapse it all. Collapse it all. The other thing you need is this tsconfig file. So I'm going to bring that up in a kind of another window. So in this window here, I'll kind of bring up tsconfig. You need to have these options in your tsconfig file. So and that tsconfig file is on the root, right? Your task runner, task.json, is inside your VS Code, right? That's what you need. When you transpile, if you've got just this, right? If you transpile, then you should be able to do it with Windows, Control-Shift-B, and then you're transpiling. All right, Control-Shift-B is transpiling your code, just like that. As long as TSC, it's assuming that TSC is in your command line. It's accessible from your command line. So you can actually go TSC space, and then the name of your code. If you can do that, you're golden. If you can't do that, that's the main reason why people are having issues with Windows, right? The other issue is there's another option here. Instead of this command structure, right, there's another one that shows you that Windows. Remember that Windows curly brace one that says Windows, and then underneath that's TSC? Remember I showed you that one as well? How to install like a TSC compiler on Windows? Did you have that configuration as well? Let me see if you let me know if you're good.
I've got the same issue where it's 1.0 and it won't.
But how does it work? Because you're able to transpile, is what I'm saying. So it won't work just because of that. But sometimes what you need to do, right, on the command line is there's a way of installing it for Windows. If I go to transpile or set up VS Code TypeScript Windows, like one of those, right? Then if I was to set up setting up Visual Studio Code, there's a couple of options, and one of them is this Windows option. I'm just gonna see if I can see it. I saw it last time where you have to make some changes to what it says. So we did this. Now see how I don't have AMD. I use CommonJS, which is what I like to use, right, when I transpile. But the one that the configuration change you need to make. See how this is what it comes with, this task runner. But you need to change the task runner so that way you can transpile. And there's an option. It's not in this one. There's an option on Windows where you set up your tsconfig file. So you look at the source maps are all the same. It just shows AMD instead of thing. With this, see this command right here where it says version 0.10 command TSC show output silent, and then there's a piece there under Windows, right, where you go Windows : and then you add this in as another before the is shell command is true, right? Let me see if I can just do it for you. So under Windows, you go Windows : and open brace, close brace, and inside as a property you put command : TSC, but don't leave it as TSC. Put tsc.exe in there. That's what you put in there, tsc.exe. If you do that, that might help you as well in older versions of TSC. TypeScript. I'll put it up a little higher, bigger for you so you can see it. This part, this piece right here. Yes, all this stuff has to be there. The problem matcher, the same stuff that we have, is shell command true, args the way it is right now in TSC. Sometimes for Windows users, depending on the version that you're using, you need to use this format with, instead of TSC, tsc.exe in here. All right, so try that out because that's the thing that'll work. But this should suffice. This form should suffice, but sometimes you need to put that in. Let's try that out and see if it works. So the only thing that's different here is this piece, this Windows piece. The rest is all the same as the other one. So if I was to look at my current version of thing, if you look at it, right? So I have version, I have command, I have is shell command, which is this one, right? I have show output silent, which is this one. I have args, which is an array, an empty array, which is this one, right? I have problem matcher, which is this one. The only thing I'm missing, and because I'm using a Mac, is this piece. That's all, this piece here. That's the only piece you have to change. And it says, look what it says, under Windows use tsc.exe. You have to put that in there under Windows, right here. Yeah.
What is in the map?
That's all you need.
So Linux would be exactly the same.
Yes, Linux would be exactly the same as this because I'm using a terminal, right? Like with Linux, and because Mac it's not Linux, but it uses a Linux shell, right? The same thing. Then it should work the same on Linux. Is it working? And give me 1 second while I just do one bit of troubleshooting, guys, and then we'll get into it. Yeah. Let's get back into that thing for a second. Where's it? Okay, it's good here. Yeah, so that's commands. Windows, this shell command true. All this stuff is good. And the thing is with tsconfig, change here. So let's do this. And then if you go, so let's just save everything. What's this? I don't need that. All I need to do is Control Shift B, and that should do it. So it should launch. We should see an effect there.
Yeah.
Sure. Let me see what does it actually generate the files and changes? Open Ocean. Yeah. There's something that's stuff here. This for a second. The other thing that sometimes works is it's not your Control Shift B, but it's also your. I wonder if there's a run the task thing. That's really weird. I wonder if it's
it has something to do with the experience.
Yeah. Anyways, let's look at doing a change. So let's say we reset to a little bit of comments.
It changed.
To me,
and if you hit the Windows space, it changes to
I didn't do
French
that.
mode.
like it actually, see it's trying,
doing, yeah.
it's trying, but it's not transpiling for whatever reason. But I'm wondering if when I do here, if you do it by the root, if I was to go into objects and we're seeing things. So if I do DIR, and if I go into scripts, bear with me, guys. I'm sorry, I'm going to do this 1 second. But if I go to objects, and if I go just try it by hand, so I go to TSC Ocean, right? .ts. Let's see if it can pass.
Yes.
Yeah, see how you're getting all these errors?
Yeah.
Right? Because this is your version of TSC is causing you to have errors. If I look at the ocean.js file, right? So here's ocean.ts, and on this one I go ocean.js, right? And this is what the output is, right? Which is correct, right? But you're getting an error on the command line.
That's exactly what you
See this error on the command line because your version of TSC is older than this one.
I've got to figure out why it's not updating when it says it is. That's a different one.
All right, so that's TSC. We'll figure that out. Maybe I'll spend some time later on figuring out more of that on your systems. Well, you can always try doing it on the machine in front of you too, eh? That's the other way you can do it. Like use a machine in front of you to download and install. VS Code is a very small install, which might work nicely for you as well. Okay, so let's get back to this. So where we left off, and I'm just going to kill this because we don't need this anymore. I do need this piece because we're going to use that for testing. So I'm going to kind of switch between those two things. And I do need VS Code. So where we last left off, we kind of had most of the pieces ready for the plane. But in order for us to do scoring or anything like that, we need to make it so that we can do collisions. Okay, so this is the next piece I want to tackle with you guys. How do we do collisions? Well, let's do some theory before for some people who don't know how to do it. And remember, when we do things with Unity or with some other game maker or that kind of thing, if you use some kind of framework, it's easy. You just add a collider and you're good to go, right? Collide between two colliders, you intersect, and you're good. But here's the problem with when we do 2D stuff, there is no colliders here in Create.js, right? You do it all manual, which is good, right? We're building it ourselves. So how do we build a decent collider? And one way is, of course, the distance method, which we can talk about. The other way is we do an overlap, right? So let's talk about both those options. So let's do some examples here. And no, I don't want that screen. So I want to bring up my project, which is this right here, all in on the Mac. And I'm gonna kind of double click a couple things here. One is I want to bring up my plane in Fireworks, right? So here's my plane. It's gonna come up in a second. Yay, my little plane. Okay, and let's expand the background just so we see what we're talking about. So I'm gonna make my canvas size 640 by 480, just to kind of mimic what we have. And now you can do it with your favorite program if you want to follow along. So there's my plane. So I'm gonna fly around. I'm down here as an example, right? And I want to collide with something like a cloud or an island. So let's do the island one first. So I'm going to bring up go back here, and we'll bring up an island. Right, so I'm going to kind of double click on the island. It's going to bring it up here, and then what I'm going to do is I'm going to take it, I'm going to copy it, and go back to the plane, and then just pop it in. So there's my island. So if I zoom in, right, and just to show you what it looks like, I got my plane. You can imagine the island's here, and my plane is, you know, swinging around this way, and then the island's going to come down. And my question to you is, do I have a collision here? It's easy to see, right? Because there's no collision. Here's my actual object, my collision object. And how about now? Is there a collision now? No, visual collision I'm talking about. Do you have a visual collision right now? Okay, but on the game, it would be, right? Would you agree, Stephen? Take a look. So no visual collision, right? But computer collision. We have a computer collision here. So this is one way we can do collisions, right? We can do collisions with, you know, these rectangle colliders equivalent, right? We could also try and use circles. So I can kind of put a circle around it. You know, let's use an ellipse, and I'll draw one. So let's say I'm going to draw a phantom circle around one of these. So there's one. That's pretty close. It's not perfect, but let's say that's pretty close. I'll just take away the fill. And we'll add in just a little bit of border so we can see the bloody circle. This is the bloody circle, right? It's bloody, like I said, right? And then let's say, for the sake of argument, right, the ellipse, let's move it around so that way it's just kind of as centered as possible. So that's your ellipse, right? And then let us make another one. So we'll just kind of copy this one because they're almost the same size, these objects, right? And so for this one, this might be okay, right? So I copy and paste and I move it over, or not the island. Arg. I meant copy and paste with another ellipse and move that over, right? So then I'll put that on top of the plane. So there we go. Okay, so now let's look at this scenario, right? Now forget the shadow, right? But let us pair the plane, approximately the plane, with the ellipse, and it's kind of, because if we're going to use one or the other, we can use, you know, whatever one we want, right? So let's just move the thing a little closer, make it more accurate. So let's say we make something like this, a circle collider, right? Equivalent. I'll move the plane around. Do I have a collision here? No. But even with the circle collider, the way it is, even if I tighten up the circle a little bit, so let's say the circle is, right now, it's pretty big, right? But see that the wing is kind of taking in the size of the plane. I can probably make this a little smaller if I wanted to. So the ellipse is 63 by 63. Let's make it, I don't know, 60 by 60, just to save a little bit of room, right? So there's a little bit tighter, maybe even tighter than that. Maybe I can go, I don't know, 55 by 55. Maybe you can get away with it, you know, from a, you know, just a raw, you know, perspective. So that's pretty good. So the wings are kind of clipped, and maybe I can pull it because I know I'm going to fly with the nose more than anything else. So I'll make the circle a little bit as tight as I can, right? Kind of thing, right? And that's it. You can't really create too much better than this. So again, what I'd say this, do I have a collision, a visual collision here? And the answer is from here at this point, no, but there would be a collision thing. So it's not quite perfect. It's close, it's better. Where I have a problem with it is not these, okay, because we're kind of close in size and shape. It's with this. So if I pull up a cloud, let's take a look at this. Now this, right? And this is the problem with this kind of shape. And this is why we have to talk about it, because there's different solutions to colliders, okay? Do I have a collision here with the plane? I do. Because see how it intersects, right? This thing, even if I made this a circle, and if I was to do the same kind of idea, right, with the circle collider, so I'm taking this circle collider and copying it and move it across, right? So let's make this circle the same thing. We'll open it up so that it's kind of the same size, and we'll even move it to front so we can see it. How about them apples, right? So we'll range, bring to front so we can see that, and then we will expand this thing so it's much larger to take up the same size as our cloud. We'll put it approximately in the middle of our cloud and make it a little bit larger, you know, and we'll I'll take the border down a little bit so you can see it. So I'm trying to be fair when I do this, right? So I'm trying to make it so that the cloud is kind of covered, but doesn't have to be 100% covered, because, you know, we try and make the circle collider a little bit nicer. More or less, you see this, right? That's kind of good. I can probably make it a little tighter. So right now we're looking at the circle is 213. Let's make it 200 by 200. Let's say we don't care too much about being a perfect collision. If you do close to the cloud, it'll make you collide, right? Even so, right? That's probably as close as you're going to get. Do I have a collision here? No, because the plane's not colliding. But what about here? How about here? How about here? How about here? Right? And that's my problem. It doesn't matter what I do with this thing, right? I'm always going to get some weird ass collision because there's no collider unless you use some kind of custom collider that's a polygon, right? Which we'd have to draw out, right? That's the only way to do that properly. And then, of course, you'd never, ever, ever want to do pixel perfect collision with 2D shapes, ever, because then your system is going to really slow down, right? So especially when you have more than one of these, or 2 or 3 of them, it's a really big lag. And what happens is it continues to slow down. So this isn't the right way to do the collisions. They're using some kind of overlap, not in 2D. In Unity, you have other options. In Unity, we set up polygon colliders, and they're so close, and they're drawn for us that it makes sense. But there's no easy way to set this up here for us, right? As an overlap. It doesn't work very well. All right, so let's get rid of these circles. So that's not the way to do it. But what about the other way, which we talked about, which is distance? So let's draw, you know, a shape here, and you notice that the center is approximately there, and here's my center of this one. And I'm going to draw a line from the center of my cloud to the center of my plane. And if you notice, I have a distance here, you know, of this object, right? How do I know the distance? Well, I draw a box, right? From corner to corner, I can figure out the distance. There's a distance formula from x1, y1 to x2, y2, right? I want to find the distance. There's a special a line here. And the way I can do it is this. If the distance between the middle of my objects, right, is less than or equal to, right? And again, because we know the object is coming this way, this works, only up and down. It doesn't work great from left and right. So example from my, the game we made for Starbase 12, I had to adjust the distances a little bit from my collision perspective. And I'll tell you why. Because if I come here, right, half my height is about, this object here is about 176 high. So half of that 176, let's say 180, right, is around 90. All right, let's say 90 pixels, right? So if this object here, we're just going to make it up and down for a second. And then my object here, this object, is roughly height-wise for my plane, the way I have it drawn right now, is roughly 50 pixels, let's say. So that's 25 pixels. So 25 at 90, right, is roughly what, 115, let's just say, right? So 115 pixels. If I have less than 150 pixels, officially, it's a collision. And that's what I'm saying, right? But it's not that. It's half of that. Because I don't need to measure the whole distance. I just measure half the distance from the middle of my plane to the middle of this thing, right? So let's draw that line. So let's just use this line, and I'll put it to the middle of the object. And what I'll do is I'll take this piece here, and we'll just swing it. And of course, let me just draw a new one. I'll swing it like this. I'll take the middle of it and go to the middle, and then how much distance do I have? 97, right? So 97 is the distance, right? And I got to say that if half my plane, which is again 25, plus half my cloud, which is about 90 approximately, if it's less than that, I have a collision. So it means that you'd probably get closer to about right here before you collide. That's acceptable for me. It's not a pure visual collision, but it's enough that it would be fast enough that I wouldn't see it. And when you get to smaller objects like this, they're literally abutting each other before you get a collision like that. That would be your collision. That's pretty close for me. It saves two things. Now there's a problem with this, okay? I'm constantly checking for the distance. I'm constantly checking to see the distance, if the distance of the two objects, the distance between one object and the other is happening. And I'm doing it every frame for all the objects in the screen I'm checking with my plane. So I'm doing one of this. If my plane and my cloud are colliding, then do this. If my plane and my my island are colliding, then do that. That's what I'm doing, right? So I can really feed in any object to check to see if the distance is happening for these kind of things. So this is the easiest way to do it, and a lot of times we use the distance formula to do that. Here's something we can do also, just to help us out. We can look at easel.js to look and see some part of our API that can help us out. So if I look at the easel.js API, right, we can look at things like vectors, because vectors can help us if we had a vector. We do not. Look how we don't have a vector. We don't have a like vector2 object here. That would be beautiful if we had a vector2, right? So vector2 minus vector1 or vector2 dot distance. And we don't even have a distance formula. I can't give you a distance, right? I can't do that. I do have, which is really going to help us, a point object. That's good. And we're going to use points for this. I also have a rectangle. That's another thing that can probably help us out. A rectangle, which is basically it's a shape that gives us x, y, and then height and width. I could do that, right? So we could use this rectangle object for height and width to determine, you know, because if I take, you know, if I want to try and, I can use a rectangle to do the distance formula, right? How do I do the rectangle as a distance formula? It's from corner to corner, right? Half the width times height, right? Or whatever it is, half base times height is what the hypotenuse of the triangle is, right? Which is really what I'm trying to do here. It's a rectangle, right? So how do I find the distance between the two edges, right? So I could do that as well. And there's some built-in stuff to use here. We're going to build our own, of course. So there's that shape. I could also use, like I said, if I really wanted to, hit test. That's something that kind of exists, you know, kind of taking us back, or an overlap. I want to kind of do a some kind of hit test or a hit checker. And I forget what the actual thing is called here. I'm just going to look for it. It's like a collision check. It's like built in for us, right? I'm not sure if it's an easel or I think it's an easel. Yeah, pretty sure it is. But I might be under bitmap or sprite. Let me look at bitmap for a second, because sometimes bitmap will do that kind of stuff. And by the way, it has properties. So let's say if I look at an index of the properties, under bitmap it has hit area. There we go. Here's a hit area, right? That it has. It also has source rect. It has X and Y, right? Hit test is the method. Here's my hit test for the bitmap. There's a bitmap hit test, right? And it says test whether the display object intersects the specified point in local coordinates, i.e. draws a pixel with alpha greater than 0 at the specified position. This ignores the alpha shadow, hit area, mask, and composite operation of display object. So I could do this. I could say something like function, handle mouse down event. I have a variable hit that is my shape dot hit test, and I compare it with my event dot stage x event, like the location on the x event, and my event dot stage y. So I have these two stage like x and y coordinates, and I can compare it with my shape, and I can know if there's an overlap, and I get a hit, right? Because my shape is whatever my shape is, and this is cool. If it's a bitmap, it's almost pixel perfect collision. There's a problem with this, by the way. Like I told you, it's a square, right? Hit test uses a rectangle, right? Okay, the other option is that's only on bitmap. We're not using bitmaps. We're using sprites. So if I go to sprite, let's see if we have the same thing. We should. If I go to index, right, and notice I also have a hit test on my sprite, right? I've got a sprite sheet. I got skew x and skew y, all kinds of other stuff. I don't have a vector object, right? I do have a point for there as well, but I do have this hit test. So I could kind of go into this view and use, because display object, I can able to do a hit test between display objects, no problem. And if I actually look at the specification, right, you actually can see what the hit test is doing. Here's my actual hit test specification. So hit test is equal to a function that returns the hit, and I basically say that the context is the display object hit context, right? That's what it is. And I do a set transform, right, of the display object. I draw a point, like it asked you to. It draws a point, and basically what I do is I say test to see that the point, right, is within the object that I'm drawing. And as long as I get that positive number, that's my test. Then I return the hit. It's a true or false that I'm returning. Not really fond of this algorithm. All right, I'll be honest with you. It's okay. It definitely supports us, you know, kind of sending in to determine whether there's a hit or not, and it gives us some examples of how to do. Again, please note that shape-to-shape collision is not currently supported by easel.js. All right, that's what it says. So this is the thing. Shape-to-shape collision is not supported. It's been the same message for easel.js from the beginning. Why? Because you don't need this. Point to point is what we really need. Okay, let's get that done without further ado. All right. So I need, in order for me to do a hit test, I'm going to do it obviously in my, first let's do it as a utility method in my game.ts, all right? Then we'll extract it as a collision class that we're going to use to test with, okay? So, and we're going to make something called the collider, right, method, just to keep in line with what we know. from a naming convention. Okay, so one is we're going to go to our game state. Here's our game state. And what I want to do here is I want to kind of sit there and say, okay, well, here's my game state. Every frame, every update, on update, I want to do a collision check. I want to do this thing called collision check, okay? Or check collision, something like that. So let's set that up. So I'm going to say, after I do my updates on my clouds, I want to set up my pseudocode here to do this. I'm going to say, well, this dot, it's going to be a private method that I'm going to write. I'm going to call it check collision. Right? That's what I'm doing. I don't have that method written right now, this check collision method, but I'm gonna write it now. Okay, so that's the first thing. This is where I want it to happen, inside my update method. So, kind of, we're gonna update this. What this does is updates the scene by every frame, right? We know that that's what it does. Okay, but we don't have this check collision method yet. Okay, so how do I write that? Well, here's my start method, and let's write a new method for our state. So we're going to write this method, which is going to be private, right? And we're going to call this thing underscore check collision. Okay, and we're going to check collision just with one thing at a time, okay, until we get the algorithm right. And then we're going to extract this method and create a class. You'll see how I build this out. And you can do the same thing for your stuff when we start off. Okay, so how do I want to check the collision? Well, in order for me to check collision, I need to, let's write some pseudocode. Check the distance. I need to check the distance between plane and the other object, right? Other object. Okay, I need to check the distance, which means I need a check distance method, right? Or a distance method. So I'm going to write a private, right? Distance method. There's my distance method. And my private distance method is going to return a number. It's going to return the distance. All right. This one, this check collision method, right, is not going to return anything for now, right? It's going to return void, right? So I'm not going to return anything for my check collision method yet. I'm just going to make some adjustments. Okay, cool. So let's do this. So if my distance, I'm going to check my distance for everything. How do I do that? Well, I need the distance between two objects, right? So I need a point and another point, 2 points, right? So I'm going to retrieve 2 points. I'm going to say, again, it's create.js.point. That's what it is. That's the first one it's going to be, and it's 0.1. So I'll say P1 then is create as of type create.js.point, create.js.point. Okay. And I'll do the same thing for P2. So the second parameter is P2, which is also of type create.js.point. So I need 2 points I'm going to send in, right? 0.1 and 0.2. I know my distance formula is it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's the square root of that. So let's write that in. So I'm going to return one line, the math.square root, right? Math.square root of, okay? Math.square root of x2 minus x1 squared, right? So what does x2 mean? So that's p2.x. So I'm going to say, so in brackets, I'm going to say p2.x, right, minus p1.x. And I want to write this squared, right, which means math.power, right, to, bear with me now, math.power to the 2, right? So it's comma 2. I'm not wrong. So power of 2, right? That's how we do math to power of 2. And I'm going to do the same thing. I'm going to add it to the same thing, math.power here, and we'll write this in. Math.power p2.y minus p1.y to the power of 2, right? So that's what it does. So it says p2.x minus p1.x to the power of 2 plus p2.y minus p1.y, right, to the power of 2, and then square root that. Now that's going to give us an odd number, guys. It's going to give us a number like, you know, it's going to be a square root. It's going to be a floating point number I'm going to return. I don't want a floating point number. I want a decimal sorry, I want an integer because my pixels aren't floating point numbers. They're integers. I want a pixel that I want to return, which means I should do a math.floor, right? Which we'll save that thing altogether. Math.floor. And I'm going to put all this inside the math.floor. So this is one big function. And I could just write this in every time, but I just feel it's easier for me to call this method and this little distance formula. So I'm going to write this in as, this is a private utility method, which is called distance. And if I really want to be nice, this is not right. This is not the right the way I should write it. I should do one of these, right? So private utility method distance returns distance between 2 points in pixels. So I want to edit. All right, so I need that. That's why it works. Let's get rid of this. These are private. This is private methods, right? So these are private methods. Okay, so that's the first. That's the first method I got. This distance stuff. So now in my check collision, which I just wrote, this is my check collision method. This is another private method we've got in here, right? I want to check to see the distance between my plane and my my island. And let's see what the distance is. I want it to report this distance on the console at all times, every frame. So how do I write that? So I'm going to go in here and do one of these. I'm going to say one like this. I'm going to say I want to get the distance if, here we go, watch this. This dot underscore distance, right? Of what? My point 1 and point 2. Well, point 1 is going to be my plane, right? So plane dot what? Plane dot, or sorry, this dot underscore plane dot location, right? So that's what I want, some kind of location or position, right? Is there some kind of way of getting my x and y in a point? Right? That's what I got to ask. And of course there is. I can separate them out right now. I can go something like this. I can say, we can do a var, local variable here in my check collision method. That's going to be, x, kind of x2, or whatever it is, or point 1. I can make it a point 1. So point, local p1 is of type createJS.point. There it is. So there's point, createJS.point. And then I can also go var p2, capital P2, is equal to createJS.point. And then I can say, now that I have those, I can say p1.x is equal to plane.x, right? Which is what I mean is this dot plane.x, this dot underscore plane.x, right? And p1.y is equal to this dot plane.y. That's the point of the plane. And now this harkens back. Here's a question, guys. Before I continue, but now it's clicking in my mind. I'm like, man, I'm writing this code, and I'm asking for points. Wouldn't it be nice if my game object had a point, a position that I could give a transform, right? For for my plane or all of my sprites, so I never have to write this crap again. And I always have an idea of where my position is for any one of my objects at any time, as a point. And the answer is yeah, that makes sense. So let's not do it here. Let's leave this annotation for a second. Leave it as is, because this is what I want. It just crinked my mind how I'm going to do this, right? Now I'm going to go back into my class, leaving it the way it is. This is undone. And I'm going to go to my game object class, or my game, which is inside my objects, game object. Here's my game object.ts. Let's write it aside from it. Here's over here. But I want this one to be my game object.ts file, right? This is all this is now. And now I have the need or the means to write my own position, right? So what is my position? How do I write this in? Anyone have a suggestion of how I create a position, basically that has two things. I want to have a point, right? It's going to be of type point. It's going to be protected, right? So let's go protected. And it's going to be called underscore, right, position, which is going to be of type create.js dot point, right? And what I'm going to do, right, now when we have this create.js dot point, right, what I want to do is in my constructor, as soon as I get my width and my height and my regex and my res y values, I want to make my point here. So it'll be like this. It'll be this dot underscore, do this one time, position dot x, right? And forgive me, this is not enough, by the way. I've declared it a point, but I need to make it a point first. Sorry, I need to do this dot underscore position is equal to new create.js new create.js dot point. I need to do that, right? Because if I don't do this, it's all useless, right? I receive points here. This is already a point when I do my distance formula here. But I have to actually instantiate a new point, yes.
Couldn't you just make it a function called point, called position?
I could, but I might as well just do it right here. Look, watch. Once I do this point, and if I open it up, right, it looks what it takes. It takes an x and a y coordinate. It's my point. You know what? Yes, but watch. I'll say this dot x, this dot x, and this dot y is my point, right? So now this position is the original position that I have, right? And what I can do in my update method, right? I can say for my plane or for other objects, I could say update my position. This dot position is equal to x is equal to x. This dot position y is equal to y, and I can continue to update my position so my point is always known. My x and y point position is known, right? I could do it that way, right? I could also create an update method for my game objects that I update inside my actual update itself, right? That I call. I say, this dot, update. I could do that, but it doesn't make any sense. So let's do it this way. Now, there's different ways. You're right. I could make it so that I can make it a function that I call, or I can just go this dot position dot x is equal to x. This dot position y is equal to y every frame. So it knows where my object is in space. It doesn't matter. It's actually a good thing because we know exactly where my position. I know my x and y positions all the time, right? For all objects on the game world, which is good, right? Okay, let's see, first of all, how we do. So this is written now. We have our game object. I'm going to transpile. That's the first thing we're doing. So now it's compiled. I'll leave this here for a second. Now that we have this, we don't need to create these, right? Because we have points already. The plane itself it has a point option. Now I have to go back to the plane and update my plane method in a second. But watch. This dot distance now, I can just go this dot plane dot position. Oh, by the way, it's a. You're right, Stephen. I need to make it either a public. I need to either make this a public property, right? Like a public variable that I have access to, or I won't have access to this thing at all. So instead of protected, we can make it. This is the ugly way, public, or I can make it a function that I get position. That's what I could do. Actually, I like the get position method more. It's more realistic. Sorry, guys. I know I'm changing directions here, but I would probably do it like this. I would make a public get position method, and what the get position method returns is returns a point, right? So it says get position, which returns create.js dot point. That's what I need, right? And how I'm going to return that is I'm going to say one of these. I'm going to say, and I can check this every frame or whenever I want, but it's a utility method I'm designing. So this is a utility method to get current position. And what I'm going to do is I'm going to say this. I'm going to fill my my boots here when it comes to this kind of stuff. Let me just close this up for 1 second. I'll come back to that. But what I want to say here is, how do I do it? So I got to return my x and y coordinates in a point, right? So I could do two things. I could declare a point, a temporary point, instead of doing this. and not even have a whatchamacallit, a private variable at all, right? So I never have to have access to it, and I don't have to do this, right? Ever. I'm just returning the position. So it's just a random point, right? That's my position. So when I do get position, it just returns my point wherever it is, which is maybe better than this, right? So I don't need this, another variable. But what I do is I do this. I have to declare a temporary variable, which is var, position, right, is equal to, which is of type, sorry, create.js.point. I'm trying to make a TypeScript work well. .point, right, is equal to new create.js.point. And what I want to do here is I want to say the x and y coordinate is this.x, and I want to pass this.y, right? So I got my point, and I'm going to return position. I could have done that in one line, but it's okay. And that's my return value. Would you agree? Take a look. So I'm returning the position. Every time I call it, I pull where my position is, and I create a new position variable temporarily that I pop into the return, and it returns it as a point. Okay, that's all it does. So I don't need this. And the reason why I'm doing that is because when I come back to here, and I say this distance, I can check the distance by going this.plane.get position, right? And then once I do that, it returns a point. Now, and because I can do that, I can do the same thing on my my island, because my island, if it was an island, also is a sprite, which also inherits from a game object. So I can go this dot underscore island, right, dot get position. I can write once and use many times. Okay, so there it is. So if this is true, if these two things, if this distance, that's what I'm saying first of all, which is up to here, this distance is less than, right, the width. I'll write on the next line for you to see it. Less than half the width of my, or half the height of my plane plus half the height of my island, we have a collision. So less than this dot underscore plane dot width. We don't have a width property. Why not? Because my width property is protected. So what do I need in my method? Get width. I don't need a get height method because I never want to check the height. Sorry, I don't need a get width method. I need a get height method. So let's write that in. Say I don't have access, so I'll do the same thing. I'll say here's another one. So public get height, which is of type, which will return a number, right? And will return, what it will return is this dot. It won't be get height. It'll be get half height is what I want. I don't want the whole height. I want half the height. So it'll do it for me, right? This dot height, right? Underscore height times 0.5. So this will be called get half height. So this is a utility method again. Utility method. We'll write this in a better way later on to get half the height of the object. Okay, and we'll write this in a little bit differently later. And I'll compile that one. Okay, go back to this one, open this up. So now this is where I can use this up here. So I go, so this dot plane dot get half height, right? And then plus this dot island, right, dot get half height. If it's less than that, then what do? I have a collision. So I want to just do, I want to show my on my console for now, console.log. I want to show it's a hit. Only a hit between my island and my cloud. Island and my plane. And the reason why I'm doing this, why am I doing one at a time? If I can test one at a time, I can do it from all of them, right? So this is the first piece to it, right? So I'm going to save this. Did you understand what I did there? So this is a bit of more than one parts. And this distance formula, by the way, and this check collision is going to be part of my collision class or collider class, whatever I want to make it. Right. For now, it's just private methods within my my object here. I want to make it part of a class because I may have more than one scene, right? So I don't want to just declare these check collisions and distance formulas again and again, right? I want to make it so I can reuse these formulas. This check collision formula or method is going to be part of my collision object, right? Okay, let's check it out and see if it works. Are you good, Jay? Okay, let's see if it works. So that's the one I want to check. So I want to go back, make sure that our server's running. It's not, so make sure our server's running here by going HTTP server. And let us run it in this thing. I'll refresh, and we'll start. And now when we hit the island, we might have a hit. I might have, so far I only have one hit. Let us do inspect element, and so we can see if there's a hit or not, right, with our console. So you notice how there was a hit for a second. Okay, so, and I can't see this thing, so I'll move this down so we can see the hit happen. So hit, see that hit? But look how it increments. That is a problem. So it only should hit once. And when I'm hitting, when I'm done hitting, it shouldn't hit anymore. What's this going to cause? Why is this? It's a good thing. It's working, right? So notice how the hit's going up, right? But not going up over here. So here it's not going up, right? But when I come close, it kind of increments, right? That's a good thing. That means I'm detecting the hit. You know, the hit is happening right now. This is good. This is a good thing, right? But that means that what that means is that it's always going to show a hit. I'm entering the hit. I'm colliding, and then I'm not colliding anymore. So as soon as I'm not colliding anymore, when there's no more hits, right? I turn my collider off. I've got to kind of turn it off, on, and off. I'm colliding, and I'm not colliding. So when I'm not colliding anymore, when the formula fails, right? When the formula fails, then I turn my flag is colliding off. Hold on, is colliding. Do I want to keep track of that in the collider, or do I want to keep track of that in the object? Because the object will hold it, and it'll hold it between calls from the collider, right? It'll know every frame I can call to check if it's colliding or not, and I can set it. It's colliding is false by default. And when I'm colliding, I set the flag to true. Then I can check in my collider if I'm colliding. Because my collider is going to be called every frame. It's going to be refreshed. But my object is going to stay the same. My object is going to carry the data to see that I'm colliding or not. It's going to know if it's colliding on its own. Is my plane colliding, yes or no? And I don't care about my island knowing it's colliding. I only care about my plane. But my island will know too. My island will know that it's colliding if I want to set it up. So I'm not going to set a specific collider just for my plane, because maybe in the future I want all objects to know that they're colliding for whatever game I'm going to make in the future, right? All right, so let's code that in. So I'm going back here to my game object. I've got these two new utility classes that are passed down to all my game objects. All of them have this now, right? But I also want to include this other thing, this other protected method that I know if it's colliding. But hold on. I got to go back to Stephen again and say, you know, should I set a flag that I can access that's in the public space? So I want to make there's going to be someone that's going to be is colliding. And for me to check this colliding, I have to save it somewhere. I've got to hold it in memory somewhere. So let's do this. So I'll say protected. Right? I'm going to make a protected, you know, property that is called is colliding, right? And it's going to be a Boolean, right? Which we're going to set by default when the object is created to false. We can do that if we want to. Not great form, right? Actually, the right way, let's do it the right way. I'm not going to get lazy. The right way to do it is when this thing is created, after regex and res y values, we're going to set this dot underscore is colliding to false. That's the right way to do it. And then we're going to make a utility method to check to see, so utility method to check if object is currently colliding. Right, it's just actually it's to hold to hold a variable, so it's flag to to check the flag on and off if it's colliding. And how do I do that? Is it a set or a get? It's both. Right? I have to do two methods. One, it's a getter, and the other one is a setter, right? I can't, unfortunately for us, I can't go into VS Code and go, like right-click on this thing and go, you know, create getter and setter. And it won't do that for me. I can't do like refactor, you know, create getters and setters. It won't do it for me. So I have to do it myself. So I'm going to say public get, or I'll say check colliding or set colliding, or get colliding and set colliding, right? Get, I'll say get is colliding. That's what I'll call it for now, and we'll return a Boolean, right? My getter always returns something, all right? And of course, I'm going to return the fact that return it, which we'll call it my collider object is colliding. This dot underscore is colliding. That's what it's going to return, right? So that's my getter. We'll say getter method. Getter method to check if objects to check collision flag of objects. What it really is, collision check collision flag of object. Is it colliding or not, right? And the next method is to set the collision flag. So setter method to set the collision flag of the object. So what I'm doing is I'm using it as a holding space, if you will, right? So I'm going to say public set is colliding. And we're not going to return anything because we're setting it. We're going to say if it's true, if I run this option, set is colliding, it's going to make it it's going to say false. True. So I'm going to say this dot underscore is colliding is equal to true. Actually, I should pass in the value, right? Shouldn't I? True or false? I'll be okay. I'll say is equal to is colliding, which I'm going to define here as a Boolean variable. So is colliding, which is of type Boolean. That's what it's going to do. So it's going to set it one way or the other, either true or false. True or false. Okay, so that's the setter. I'm going to save my getter, my setter. I could have accessed it. I could have made this a public property. Here's the question: in my constructor, should I use the setter method or should I access the protected method, the protected object here? What should I do? Should I use my setters or my protected object? And it's okay to use the protected object because we're inside the class itself. Some people you may see actually start using the setter that right here. Set is colliding right in here. They sometimes do the setter right in here, right in the constructor, right? Because it's written down here and I can use it automatically. But it's not necessary. Okay, good. So now that we have set is colliding, we want to do one of these. We want to say, okay, fine. If it's true that I'm colliding, right? And by default, the object's not colliding, right? Every object I've ever written. I can always say something like this. I want to check to see if my object is colliding. And if it's not, right? If it's already colliding, don't register a hit. If it's not colliding anymore, right, then register a hit. So how would I do that? Well, I don't even want to check the distance anymore if it's already colliding, right? I don't want to set the distance anymore, right? But if I don't check the distance, I can't tell if it's colliding anymore, right? So I know that if this is true, then my plane, this dot underscore plane dot set is colliding, it's got to be true if I'm here, right? Because I've already got a hit, it's just colliding, right? Cool. So this is where I set it. Well, I got to check if this distance, right? If it's a thing. So this is my if statement. Well, if it's else, if it's not colliding, it's here. I can say else, then, right? Because if it's colliding, if the distance is true, then it's colliding. Otherwise, this dot underscore plane dot set is colliding for false. right? True or false? So now I can check to see if it's colliding, and if it is colliding, right? If it's true or false, I can check to see if the plane is colliding, get is colliding. And if it's already colliding, I can check it somewhere else to say if it's colliding, don't play that moo sound anymore, right? I don't want to play it more than once. I only want to play one time. Well, maybe I don't even need the other the getter. All I need is a setter, which is kind of weird, right? So I'm setting it either true or false. I'm just flagging, setting the flag, right? Okay, so I only want to register a hit if this dot plane is set the is collider is true, and I want to check it. So how do I do that, right? So I don't just check if the position is true or not, right? So I check to see if it's true. If I do, I set it. Else I don't, right? But I don't want to even do this hit here unless it's I don't even want to check this anymore. Once this is set to true, I don't want to check the distance anymore. I don't want to be able to. I don't want to set this hit happening anymore if it's true. How do I do that? How do I set it so that, you know what? I don't want to register a hit, as an example, if I'm already colliding. How do I do that? But I want to check to see if the distance is true or not. If the distance is there, right? Anyone have a way of doing that? So I'm checking the distance, right? If I'm in range, then I want to show a hit, make a noise, add some points, whatever I'm going to do for the island, right? If I'm in range, and then I'm going to set my collider flag to true. I'm colliding, so please don't keep registering points for me, because I can just keep running over my collision over and over again and keep getting like thousands of points if I just keep staying in that same spot, right? I don't want that, and I'll play my sound like like one of those, right? As opposed to one time. It won't say yay, it'll say yay, like that. So it'll play that sound over and over again. I don't want that. I only want to play it once. So how do I do that? What do you recommend, Jay? So I detect if it's colliding. Yes, it is, right? I set the flag to true. Now when I come back to this thing again, because I check this every frame, right? Where can I check to see that it's colliding again? Where do I want to? I want to turn this off here because I checked, it failed, right? And it's true. It's not colliding anymore. And here's the other question: do I want to set this plane is set as colliding to false here under my else statement? And I could, but that means it would always be false, and it would never work, right? I could say get, but then if I check it here, if it's not colliding, I can check to see if it's colliding, right? Okay, so I could do that, but that means that this whole thing would have to be covered in an if statement. Would you agree? Let's check this out, huh? Where? But if I put it inside here, right, if I check, I already know that it's colliding because of my distance, right? So that's what I'm saying. I think the other way is better. So I would say up here, I'll do if this dot underscore plane, right, dot get is colliding, right? Check if it's true, right? That's what I'm checking. And by the way, if it's false, it'll give me a negative, right? If it's colliding already, right, then I don't want to check this out, right? So I want to say if it's not colliding, get is colliding is going to return the state of this thing. So I don't want to say if it's not colliding, if not this dot plane dot underscore is colliding, then, by the way, when we write nots, we know there might be another way to write that in a more positive way, right? And then what I want to do then is do one of these, right? That's what we're saying. Check to see if it's colliding. Check if plane is already colliding. Is not already colliding, right? It's not already colliding. If it's not already colliding, cool. If it is, then skip this, right? Okay. Well, hold on. If it's not already colliding, right? If it's not already colliding, then if it's already colliding, it's never going to get here, Jay. So this is the thing that we have a problem with. So let's look at the logic a little bit, because we we have to kind of understand what's going on here, right? So I'm saying if the plane is not colliding, then go here. And the first time we run the plane, it'll go here. It'll say, okay, now you're colliding. Okay, when I come back here, it's going to say, you know what? You're already colliding, so I don't want to check anymore. And it's never going to do it again. It's going to check one time, right? So this, nice idea, right? I can't do it this way. I have to be able to kind of come up with a way of doing my check at the same time. How do I do that? So this is what we're going to do. We're going to do it in the same line. So we're going to do one of these. Let's take this out. And we'll take one of those out. And inside my if statement, where I say if this distance and blah, 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 I can say if, you know, it's both conditions have to be true, right? This blah, 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 blah distance, right, is true. And I could say that, and is not colliding, or is colliding is true, or is not true, then check. That's the same thing that I would have done if I put it in there. And else, if it isn't, set the is colliding flag to false. But if I set it to false right away, right, that's not good either, right? So any suggestions? How do I fix this conundrum? Because either way, I check. So here I check. It's true. I set it to true. Okay, cool. It comes around again, and then it checks the distance again. Well, it's already true. So if this is true, then I don't register a hit anymore, right? And I keep going. If I check again and it's false, right? As an example, if this is false, then I want to take it out of collision mode, because I don't even go here if this is false. So I still want to go in here all the time. I always want to check the distance, because that's going to tell me if it's true or false, right? But I don't want to register a hit every time. I don't want to register a hit every time. And the way we're going to do that is this. If this is true, right, then the distance is working, right? Then I register it as a hit. I register it a hit, right? Then I come back and I say, okay, cool. Check the distance again, right? Am I already hitting? If I'm already hitting, don't register my hit anymore, right? And when this is false, if I'm not already hitting, then set this to false. So what I mean is, inside this, I'm going to say this: if this dot plane, which we'll call it dot get is colliding, right? If it's true, right? So if it's not colliding, like we said before, if it's not colliding, then right, register the hit. Console.log hit. Check to see if it's already colliding. Here it is. Register the hit. If it's not colliding, and then we set these two things to true, right? Because that's what's happening right now. However, if I come back here and we're already colliding, don't do anything, right? Wait till the distance is false, and then in here in my else statement, then I want to set this dot underscore plane dot set is colliding to false. Right? So I'm not colliding. This checks to see if I'm colliding. If this is false, so I know I'm not colliding. Set it to false. Now if I come and check it again, if it's true, then I'm going to check to see if it's colliding. If it's going to be false, right? This statement is going to be true. I'm going to hit, and then it's going to set this plane is colliding to true, which means it's going to skip this a bunch of times, right? It's going to check this, but skip it a bunch of times until it's not true anymore, and then it's going to set this to false. So this is the algorithm right here. Let me just update that, and I'll show you what it is. So it's a little bit tricky, right? But only because it's a logic thing. You have to think this out. If I'm going to go through my code, I come here to my first statement, check the distance. If it's going to register a hit, this is my logic, and I'll say it one more time. That's cool. That means I have a hit. Okay, cool. If it's the first time I'm hitting, right? So if it's not already colliding, make it a hit. And then set is colliding to true. Now I come back around. Am I colliding? Yes, I am. Am I not already colliding? No, that's false. So don't set this to true anymore. Keep coming around. Keep coming around. Keep coming around until this case fails, and therefore make it false. I'm not colliding anymore. Okay, let's check it to see what I'm talking about. So I'm going to first of all cross transpile, right? There we go, transpile. And now I'm going to go back into my code here and refresh. And let's see how many hits I get now. So start, and as I go to this, sorry, here, I get nothing. Uh-oh, nothing. This is where we check to see if it's a hit, right? Hit, okay, la la la. All right, so we have an error. We don't have a syntax error. We have a system error, like I wish we call systematic error that we're making, right? So it's not really doing what I'm asking it to do. Look, see, I'm not colliding at all now. That's bad, Stephen. You're not helping, so I'm trying to rough this out on my own. It's all your fault. Gotta blame somebody. Okay, let's get back and see what the problem is, right? So let us do a couple things then. If I'm checking to see if this is hit, and now I'm saying if not, this plane is colliding. Let's check up here before we do our check collision. What I'm going to get is colliding right now. So I'm going to say if console.log before we check, right? What this thing is, right? So this dot underscore plane dot is colliding, or yeah, sorry. Not is colliding. That is colliding. Let's see what it gives us. Does it give us a true or false? Right. So every time it checks to see the first thing, so return true or false if this thing is colliding. Right up here. Right before we do the check. So this is one of my debugging steps. Okay, I'm going to transpile. Yay. Okay, cool. Let's check this out now and see what happens when I refresh. So I start play and then false. Look at how it goes false the whole time. False, 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 false. False, 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 false. Oh, false, 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 false. It's always false. That's good. It means when I come in, it comes in as false. Okay, that means. My statement, my conditional statement right here, when I check if this is true, right, I'm actually checking if it's not true, and that's the problem. Right, so let's take that flag off, save, because I'm actually checking to see, oh, yeah, this is another one. Look at this. I didn't do this. Yeah, well, you know how it is. So if this stop playing is colliding, it's true, then console hits and da 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 da. But I don't want that. I want it's not true. So if it's false the first time. Okay, cool. So I made a mistake. I just didn't put this in here. Look, these two brackets. I didn't have that in there, and that's why I couldn't do this. So this worked, but not that one. Let's check it now. So transpile, minor error, we fixed it, and let's go back and see if it's colliding now. So run it, set it, and we're saying how it's false, 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 false. But when it comes to going over the thing now, I got a hit, and it only happened once. Take a look. So our logic works. So hit, right? Hit, hit. So it's happening now. Is it's going over one time, and when it stops colliding, it resets my marker to false. Right? So now it's worked. This is the algorithm, guys. Once I have this in place, I can adapt this one not just to my plane and my island, but to my plane and any object. And because both my island and my clouds are both game objects, I can test to see if it's a game object and which one it is to get my hit. How do I check which one my game object is? Well, this is the really cool part. I kind of already have it half in place, right? In my game object, right? Remember that I take in an image string, and I set the image string inside my sprite, right? My image string. I don't keep track of it, but it's not like I can't, right? So I want to return my name of my of the string, right? So let's make that kind of a new protected variable, protected, and I'll call this thing my name, the object's name, right? And I'll make it a string, and I'll say this inside my constructor. I'm going to set my image string. I'm going to send this image string into the superclass, but I'm also, the first thing I'm going to do is I'm going to say this dot underscore name, right, is also going to be equal to the image string. Right? So I've set my name. My name is plane, my name is cloud, my name is island, my name is ocean, whatever I want to set my name to. So I know I have my name. And now, just like we did in doing Unity when I said get tag name, this is my tag name, my name, right? So my name of my object, I know. And that means I can test in one collision object, one collider, if you will, I can test which object I hit with, right? Okay, cool. But I need another get method, a getter, right? So I'm going to say, you know, again, getter method to check or to get the name of the object. That's what it does. The name. So get name will be the method, right? So public get name, which is going to return a string, and we're going to return this dot underscore name. So get name returns name. It's going to return it out inside this method. So now I can do this. So my collider, this collision method that I'm using right now, right, that I'm calling every frame, which is called check collision. I don't want to just check collision with one thing. I want to check collision with whatever I send into it. So let us try this out with the island, and I want to make it more generic. So here's where I'm making more generic the class. I'm going to say this. I need to know which game object is colliding. So let's talk about this as I want to kind of take in a game object, right? And we're going to call this thing object, like this. Watch. So I'm going to say object, lowercase object, right? Be careful with the words here. It's going to be of type objects.gameObject. It's kind of weird, but that's what my object is going to be called. So I'm taking that in as a parameter now, right? Objects.gameObject, right? Object then, this local parameter object, is going to be whatever game object I'm sending in. Right now, I'm sending in a check with the plane, the island. Watch, I'm going to say this dot underscore island. I'm sending into this thing. So I'm checking the collision with the island. Okay, cool. Okay, cool. So I send in the collision with the island. That's what this thing does, and to see if I've got a collision, right? So I received the object here, and now what I want to do is I don't have to check to see the island.getPosition. It's not going to be the island. It's going to be the object.getPosition, right? So how do I do that? I don't need this anymore, by the way. This check is done. I've already proven that it collides nicely. I want to just check it for the island again and replace this stuff. So I'm going to say object.getPosition, right? And anywhere I see island, I'm going to change it to object, right? So object dot. Just undo this for a second. Sorry. Instead of the island, this dot island, I want to say object dot get half height. So I'm getting the object here. I'm trying to make a generic function, right? So here's my object, which is of type objects.gameObject, the one I made, the game object over here, right? I'm receiving this as a parameter, and I'm saying, take my plane and compare it to this object. If the distance between these two objects are good, as an example, then I have a hit, and then do the same thing as normal. It's always going to be my plane because you know, is this kind of stuff that's happening. Make sense? So this is now, it's more of a generic function, and I can use this to check not just my my island, but my cloud, right? Or any other object that I want, any other game object. Okay, let's check to see if it works, because this is my little collision that I want to make sure that it works. That's happening right now. Before I kind of go further, all right? So transpile, and all I've done is change the names of island to game object or object to protect the innocent. Here, let's try this out. So go back to here, refresh, and start. And now I want to hit. There we are. Look at it. Here's another hit. And here's a third hit. So it's working nicely. Look. Hit. And over here, hit. We're good. And now, because we're checking this object, what we're doing is we're checking an object, not the island, because island and cloud are both game objects that we've defined. This check works. That's why it's a really great thing to use a superclass like game object, just define both objects, because I can check to see what they are. Now, if I want to check to see if it's an island and give it a hit, a special sound, and if I want to check to see if it's a if it's the cloud and give it another sound and subtract points, that's easy to do. Like, watch, I can do one function for that. So I go back to this. And we should probably stop and take a break in a second, at least until, because we're kind of more than halfway. So how do I check that? Well, I say, what is this, right? I say, if this plane is not colliding and I collided with an object somehow, and I want to register a hit, but I want to check to see what kind of thing it is. I can say, well, if then other object, right, dot get name, right, is exactly equal to island, right? If that's true, and get name has to be, of course, the way I should make it, like this. If it's equal to island, then it's an island hit, right? And if it's equal to, I'm going to make another if statement, object.getName is exactly equal to cloud, right? And now you're going to say, Tom, why don't you use a switch statement? As I should. I could. Because I can switch object.getName, right? Whether it's an island or a cloud, depending on what the string is. That's the better method. And so I should probably do that instead of using F statements, right? So let's wipe this away, because I saw Stephen's face and he just reminded me of this whole problem that I'm causing. It's my fault, of course. So what I want to do then is say switch, right? Object.getName, right? And remember how switch works. I'll say case, and the name of the object, which would be island, then break, and then case, if it's a cloud, then break. We want to do those two things, right? We don't want to say default, because all other cases we don't care about. So if it's an island, then we want to say console.log island hit. And then if it's a cloud, right, console.log cloud hit, right? It's a little case statement that we're writing. And we'll kind of save that. Either way, if it hits one of those two, right, it's got to be this dot plane is colliding, it's equal to true, right? And we're not going to collide anymore. We're not going to check collisions. We're not going to go through this check anymore. So this can stay here, either one. Whether it's a plane or island or a cloud, doesn't matter. It's a collision, right? We don't have to do that in here like twice, just once. If it's something else, right? If I'm checking something else, some other game object, right? I don't care right now, so I'm ignoring it. I'm not going to pass in the other game object anyway, right? But I could make another check, like default then. All right, so let's check to see if this works the way this is. So I'm going to say kind of transpile, and then let's take a look and see how it's working on the actual game. So I'm going to go localhost, and then we'll take a break. Localhost 3000. And what am I doing wrong? Oh, locals is 8080. I'll be okay. 8080. And let's just refresh to make sure that the script has been updated. And let's also do an inspect element and look at the console. And now I'm over here and island hit. Island hit, right? So this island hit, the check to see if it's an island works. Now let's see if we can make it really quickly. So we can check to see if this check collision is with a cloud. So I'm going to say one of those and copy and paste. Check to see if there's a cloud collision. Uh-oh. I don't have one cloud. I have clouds. So where would I do my cloud collision, gentlemen? Inside here, inside my loop, right? So I'll take this little collision check, right? And I'll cut it, and I'll put it inside this after I set it. And I update my cloud position. I check instead of island, I send in cloud. Right? Now, argument of type number is not assignable to parameter type game object. Oh yeah, cloud's cloud. I'll be okay. Okay. Make sense? So it's going in there, it's checking for cloud hits, it's checking for island hits, and it's doing that inside my my game. Now this is going to be almost the same when we write our class, except we're going to say collision.check, which we call it check collider or something, or whatever it is, or my collision.check. Collision.check. I'll make a check method that checks to see if it's a collision, right? Okay, let's check this out, and let's see if this works now. So I can do both island and cloud as my collision check. So refresh, go here. Oh wait, I probably should transpile, huh? What do you think? Transpile. Yay. And now I'll check that out. Refresh, and let's see if we have that. So start, and I have cloud hits, a bunch of cloud hits, and I have oh, an island hit. Uh-oh. And now it's not working again. How come? I did one thing, and then it's doing the same thing. How come that broke it? It's registering different hits, right? I'll tell you why it's registering different hits. Because of the way we structured our switch statement. In our switch statement, we say, regardless, set if this plane is not colliding, then in here, right, do a switch statement on object.getName, and depending on which one it is, console.log cloud hit, and then down here, right inside my switch statement, set this is colliding to true for the plane, right? So my collider for the plane is true, but you know what happens? I'm setting the wrong collider to true, right? Because my plane is colliding, therefore it won't check to see if it's a collision, right? And then it'll reset this thing because I'm colliding with more than one object. So what am I really checking to see if it's true? Not that plane is colliding, but rather that it's my island is colliding. So I said my island is colliding. If it's true, then I don't do it, right? So how do I check that now? So it's not plane, but rather object, right? So if object.get is colliding, right? Because remember, I set my object. I didn't check my plane, right? This is the colliding method is colliding is actually part of my game object, not my plane, right? So if not object.get is colliding is true, which is good, right? Then object.get, do the object.getName thing and set object on each object, not my plane. I don't care about my plane. My object will set if it's colliding or not with that particular object. And then the other one is object. Okay. So it's not my plane that's colliding, but rather my object that's keeping track individually. And let's transpile this. Now there's less plane and more object. And let's see if that works. And refresh, and start, and island hit, cloud hit. That's good. Look, cloud hit, island hit, right? Island hit, cloud hit. This is good. Look. So now we have individual hits for my object, and we'll take a short break. When we come back, we'll start setting up scoring, and we'll start setting up our sounds for collision sounds because we're ready to go now. Now that we got our collider working, we can pretty much get this done, and then we'll set up our collider class after that.